chemistry class, boys and girls. Are we ready to begin?
No.
Yeah. Let's do the bell work problem, number 174 today. Okay, so take your bell work books out. Let's look at 174 in your textbooks. For those of you not here, this was your bell work question today. Make sure it gets in your bell work book, because you'll be responsible for it. 174. The Statue of Liberty has turned green because of the formation of patina. Two copper compounds, that one and that one, form this patina. Find the mass percentage of copper in each compound. This actually is not an empirical formula problem, it's just percent composition. So we're actually doing two problems here. The first one is this copper compound. Somebody read it to me because it's got a lot of elements in it. Houston, you got it?
C.
Okay.
OH, C4. That's a 4.
Okay. Have no idea how to name this? Don't ask me. Okay, and the other one's Cu2,
C4.
Cu4,
OH, 6. SO4.
SO4. Okay. My guess is it would be copper 2 tetrahydroxysulfate, but that gets really weird, so let's not. We're asked what percentage of copper is in this and what percentage of copper in this. So this goes all the way back to something we did last Wednesday in class. What is the percent composition of a compound? In order to do so, we need to figure out the mass, the molar mass of the whole thing, and then divide 3 coppers worth by the total. Remember, percent composition is part divided by the total. So first thing, we'll add up 3 coppers. 4 plus 4, 8 oxygens, and 4 hydrogens, and 1 sulfur. And over here, we're going to do exactly the same thing, but we got 4 coppers, 10 oxygens, 6 hydrogens, and 1 sulfur. Okay? And somebody give me the, Will? Yum?
You want the, like 3 times that?
No. Give me the periodic table,
Okay.
atomic mass for copper.
63.546.
Okay. Oxygen 15.999. Hydrogen 1.008. Sulfur 32 points. I always forget the last
0.65.
0.46 or 0.64?
0.65.
Huh?
6.5.
6.5? Okay. So then we multiply these out. 3 times this, 8 times this, 4 times this, and 1 of these, and add them together. Okay.
Our book says 0.66. I mean 0.066.
That's okay.
Cool.
Okay. And so that'd be 180 something. Who's got the total? Anybody figure this out? William?
239.727.
727. And so, in order to calculate the percent, everybody agree?
No.
No? Okay. 189, 191 and a half roughly. I'm rounding this off. 16 times 8 is 80 plus 48, 108. That's going to be 4 roughly, and that's going to be 32. So I got 8, 12, 14, 16, 100, 200. Yeah, it's going to be over 300. Something went wrong here. Okay. Somebody? Olivia?
354.728.
Okay. Let's see. Anybody agree? Disagree? Look good? Okay. We can ballpark it by rounding off just to double check our numbers real quick. And again, so if you see me round off, I wouldn't do that on the test or quiz, but I've rounded off here 36, 144 plus 191, 330. Something like that. Okay, how do we get percent copper? I take this number, or the actual number, and divide by this number. So I'm going to round off again, 191.5, divided by 354.728, multiply by 100%, and we get the percent copper. Answer? Calculator people here, Ken?
53.7.
53.7%. And the answer in the book says 53.74%. Good. I'll take it. Okay? Same thing over here, same process.
Do
Kristen?
you want us to round up to 54?
No, I definitely leave at least 1 decimal and usually 2 decimals here. Again, we're not given any starting number here, but just within reason, 53.7 or 53.74 will be reasonable. I don't want to round that off to 54%. Can you shut the air off, the heat off for me? Yeah, just hit the right-hand button just once. Okay, same process over here, but we have different numbers. 63 times 4, 10 times oxygen, which should be approximately 160, 6, 32, and that's 142. No, it's not right. 63, 120. Ooh, that's weird. What's this times 4, buddy? Houston, 254. 184. Okay, same process, add them up, get a total, and now we're going to divide the 254 by this total. 4.184 divided by, just get the total, Houston.
452.287.
And percent. Michael's got it. Just read me the decimal.
Point 56.
56 what?
2.
56.2%, does that sound right? Book says 56.20%, nice. Yeah, you have to multiply by 100. Don't sweat it. You can always stop after the decimal and just move your decimal 2 places and it tells you the percent. Okay, the only tricky ones are going to be if it's less than 10%. Question?
No, actually, don't. It's fine.
What? Percentage thing?
Yeah, I did all of them.
You can, but it doesn't ask you for all of them.
I did.
Question is find the mass percentage of copper in each. If it just said find the mass percent of all the elements, then we'd do all of them. Good job, Edwin. Okay? And those are the problems we did last week in class. This one just says copper. So 53.74, 56.20%. And you should be able to do it for all the elements. We just take this divided by that, this divided by that, and this divided by that. Okay? Let's try the problem that is number 66. If you have it on your homework and you did it yet, then you can take it out and check your answer. If you didn't do it, because I'm going to check your homework tomorrow, then follow along now. Okay? Pain reliever morphine. Who doesn't love a chemistry question about morphine, right? Yielded the data shown in the table. Okay, and we're on page 350. Determine the empirical formula. No, that's not the one I want. Sorry. That's a fun one. That's crazy. Crazy formula. Anybody got something really crazy? Good. Don't say it out loud. Don't say it out loud. Just don't say it out loud. We'll save that one for the end of class or tomorrow after everybody does it. 60. I'm looking for a specific one here, but I don't know which one of these does that. They don't. The answers don't look like that. Let's just see. Let's go back of the book. Where's that supplemental section? There we go. Chapter 10, supplemental section, page 982, if you would like to follow along. Let's do number 30 on page 982. Eucalyptus leaves. Who eats eucalyptus? Trivia question. Raise your hand. Go ahead. Koala bears, yes. Okay. Koala bears love that eucalyptus leaves. Eucalyptus leaves are a food source for panda bears as well, according to this question. Okay? I know they eat bamboo, but evidently they like eucalyptus as well. Eucalyptol is an oil found in these leaves. The analysis of eucalyptol indicates it has a molar mass of 154 grams per mole and contains the following composition. Determine the molecular formula for eucalyptol. 77.87. Number 2, hydrogen, 11.76. Number 3, oxygen, 10.37. Okay, let's see what we got here. Now, I've gotten in the habit here of drawing columns, and that's a good way to keep these kinds of problems organized, okay? First column, we're going to change these into grams. And it's always going to be the same numbers unless it tells me a specific number of grams of each of these. So a few of the problems actually start you off with grams without even telling you percentages. And we can have the problem start like that. But for now, we're just going to say, 100 gram sample. And we're going to copy these over. 77.87 grams, 11.76 grams, 10.37 grams. What's the next step? Triana, what do we need to do next? Change these numbers into what? Moles. Yep. So my next column, I'm going to say moles. In order to get from grams to moles, we need to use a conversion factor called the, Kristen? To change from grams to moles, we need to use a conversion factor called the, Emily? No, not that one. Definitely don't use that one. JP says molar mass. Okay, well, molar mass changes mass to moles, okay? Molar mass changes mass to moles, and it's in grams per mole. So, here, carbon, hydrogen, oxygen. Does everybody see, by the way, how many different things carbon, hydrogen, oxygen do? You're starting to get an inkling about that. We're going to multiply this by the molar mass of carbon, 12.00111 grams over 1 mole, or 1 mole over 12.001, whatever that says. And then this one, 1.008, 1 mole. And this one, 15.999. Just let it roll off the tongue there like a German. Which means no. No, no, no. That's what you say when your little kid's about to touch something hot. No, no, no. 999. That's good. Okay. And so we're going to divide these. I need some help with calculators. Will, what you got for the first one?
6.48.
6.48. 11.76 divided by 1.008. Here's your hand if you got it. Kristen?
11.7.
11.7. Good. And 10.37 divided by 15.999. Houston?
0.648.
Okay, 0.648. Okay, so these are definitely not the same numbers. They're not whole numbers. I can't write an empirical formula yet. So, what's the next step? Brinkley, what do we do next?
Divide all of them by 0.648.
Okay, we choose the smallest one and divide that into all three of these. In this case, 0.648, 0.648, 0.648. And this column is going to be called mole ratio, I'm going to call it. Now the obvious one, I don't need a calculator for the first one, right? That's cool. And I don't need a calculator for the last one. Oh, actually that's 10, isn't it? Yeah, 6.48 divided by 0.648. And the last one's going to be 1. By the one you always divide by first is the one that's going to be 1. But somebody, I need some help calculator-wise with this one. Houston? 18? 18 exactly?
0.05.
Yeah, sounds like 18, okay? So we have three whole numbers. Ta-da! What's our formula for empirical gonna be? Show. First number is 10. Second number, 18. Oxygen, 1. Wow. Okay? Now, that's not our answer. The question, let's go back and read it again, says determine the molecular formula. So like we did yesterday at the other class, this is an empirical formula. Let's label it. And I need to find the molecular formula. And they give me, as part of the problem, the molar mass for the molecule, eucalyptol. And they say it's 154 grams per mole. We're going to divide that, by the way, we'll say it's 154 grams per mole. We need to know how many grams per mole this is. Then we divide the two numbers, figure out what the ratio is going to be. So, 10 carbons, 18 hydrogens, 1 oxygen, let's call it 120, 18, and 16. Okay, I'm rounding off for the sake of speed here because I know it's good. This is only out to the ones digits, so we can do the same thing here. 8 and 6 is 14. 5, 1, 154. So we're going to take 154 grams per mole for the molecular formula and divide by 154 grams per mole, which is the empirical formula, and they are the same. Okay? So this is both our empirical formula and the final answer, molecular formula. Both. Okay? And you can have that.
Wait, where did the 120 come from?
Where did the who?
The 120?
10 carbons. 10 times
okay.
12. Okay? Carbon
Okay,
is
gotcha.
12.011. Okay? And nitrogen, hydrogen is 1, so 18 times 1 is 18. I'm taking some shortcuts here because you've seen me done this. You've seen me do this a lot of times. Okay? So I just a real quick molar mass for this stuff is the same as the molar mass that's given in the problem. So the molecular formula here is the same as the empirical formula. And can you double check, is there any common denominator between 1, 18, and 10? No. Okay, if one of them is 1, that's the lowest those numbers are going to get. I cannot divide two of them by 2 and not the third one. Okay, so this is the simplest form, and it is eucalyptol. Pretty cool name. Let's do another one of these. I think we're on the same page, right above it, number 29. Analysis of a compound used in cosmetics. Okay? You want a chemistry field that's cool? Go work for Mary Kay. And not selling stuff. Make this stuff. That'd be a cool job, I think, personally. Okay? Any of the big names, and I don't know, but you do, that makes cosmetics, or that make perfumes, or that make shaving creams, or that make hair conditioners. Guess what? Those are chemists that do those things, that dream up these new conditioners for hair that make your hair silky smooth. Okay? Or coloring agents, or dyes, or cosmetics, or all the different colors. Crazy stuff. That'd be a cool job, I think. Carbon, hydrogen, oxygen. Oh no, again? The one right about 29. Let's go back to back. Carbon, 26.76%. I think. Where's it at? Yeah, wow, amazing. 2.21 on the hydrogen. And the oxygen, we got 71. What? No, it can't be. Yeah, it is. 71.17%. Okay. Same steps. Why don't you take 5 minutes or less? See if you can get it done. You got it done, raise your hand. I'll check the answer. We're gonna do exactly the same thing we just did on the previous one, okay? Make your columns, we're gonna say grams, moles, mole ratio, and when you get that far, stop and let me know. Because I'm gonna do it too, but not on the board. I was trying to figure out the crazy bell schedule if we had gotten out of chapel at 10:50, but we didn't. We're down to 20-minute classes if we got them all in. That's a heap of oxygen. Does anybody need a calculator? Everybody got one? Gotcha. Just ask, guys. Just ask. Anybody else calculate? I want you to feel comfortable because there is this whole test, this whole chapter is this stuff. This one's easy. Boring. Okay. Oh, good. There you go. Okay, so you're right so far. Good. Yep. Uh-huh. Yep. And then, 12, not 17. 12. I don't know if that's your writing or if you just looked at the wrong number up there. Hang on.
I'm not done.
Yep. Yes. Good. Good. Yeah.
Once I get that and then dial that in back, and I just do it.
Double more. Yeah.
It would be
Yeah, we'll go over it in a second.
Should be really close here.
I think everybody's on the right track. Okay, a couple of you not finished, but let's crank the numbers here real quick. We're going to have 26.76 divided by 1 over 12.011. Okay, and then we're going to have 2.21 divided by 1 over 1.008. And then we're going to have 71.17. That's a cool number. Notice the dyslexia thing here. Okay. Divided by 12.011. What's that when something is a mirror image of itself? In English, what do you call those words? No, it's a special word. Words that are spelled the same forwards as backwards.
palindrome.
Yeah, that's a number that's the same forward as backwards. Isn't that cool? 71.17. 71.17. Anyways, so you get some number of moles here. I got this, and most of you are really close. 2.23. 2.2220, that's what I got. And again, I rounded off a little bit, and 4.45. Divide them all by 2.2, roughly. And most everybody here got 1, 1, and 2. Ta-da! So our empirical formula is CHO2. Cool. Now, let's go back and reread the problem. Determine the molecular formula for this substance if this molecular substance has a mass of 90.04. So we need to figure out what the mass of this is first, empirical. So we take 112, 2 1s, and 2 16s. Yeah, 12, 2, and 32, basically. 2, 4, 6, 46.
How are you doing that?
Which one?
What do you add?
I'm doing these really fast now, Emily, because we've been doing these for a week. So 112, that's one carbon times 12. 1 hydrogen. Oh, that should be a 1, right? Is that what you mean?
If I wanted to really fast.
I'll take a bonus one.
And 2 16s. 2 oxygens times 16. Okay? That's a 16. Does that satisfy you now?
Yeah.
If I had 1 there, you wouldn't have asked me?
No, I still don't know how to
Okay.
do it. But most
1 carbon, 1 hydrogen, 2 oxygens. It's just the molar mass. The molar mass is the mass of 1 mole. Everybody? The molar mass is the mass of 1 mole in grams per mole. So 46 grams per mole.
45.
45. The total.
Yeah, that's what I said up here. So we take the number that's given in the problem, which says the final molecular mass has a mass of 90.04 grams per mole. And you can sort of look at these two numbers and say, aha, it's going to be twice as big. Okay, but we're going to take molecular mass. If you want a formula, it's molecular divided by empirical. If you like formulas and you want to write that down, that's going to give me the multiplier. And the multiplier is 2. Somebody over there said, yeah. Now what do I do with it? Multiply the whole thing by 2. So it's going to be C2, H2, O4. And again, if you do the molar mass for this, you'll get 90 instead of 45. So that's our final answer. Good. Yeah, I'm proud of you. You guys are doing really well. Still haven't found the one I'm looking for, so we're going to keep working with more problems like this. Now, this is kind of like the crowning achievement of this chapter, guys, because if you can do one of these problems, like you just did, and get it right, it tells me, number 1, you know how to do a molar mass for an element. Number 2, you know how to calculate a molar mass for a compound. Number 3, you know the difference between an empirical and a molecular formula. Number 4, you know how to use a molar mass as a conversion factor to change from grams to moles. So there's like 5 things we've learned in this chapter, and you're using all of them to do this problem. Okay? So this is as tough as it gets right now in this chapter, in chapter 10. Okay? If you can do this and you got that problem right, 2 thumbs up. You're sitting good. Okay? Keep practicing, keep reviewing. Okay? And we'll do some more of this tomorrow. Now, let's look at, I'm still looking for one that, let's try 27, right above it. Analysis of the compound indicates the percent composition of sodium, phosphorus, and oxygen. Finally, we get away from the CHO, okay? So, sodium, phosphorus, and oxygen. 1889, 3904. 1889, 30 something 04. What is it? 30, 39, and what element? Oxygen. Okay? Okay, take 3 minutes. See if now this one we're just going empirical. So don't worry about that last step. Don't worry about molecular formula. We just want to know empirical. Okay, so we're going to change grams. You can just cross them all out, change them to grams. We're going to change into moles.
Thank you.
Mole ratio. And then the formula. I figured it out too. That's easy too. Okay. Still not what I'm looking for, but that's okay. Let's see a point. That's it. That's it. Yes. Yes. I am happy. Hi. Oh, you're the girl that writes in her book.
In A3 PO4.
It is. Yep, yep, written down. Yep.
All right.
Listen, clear my calculator.
Where are those coming from?
Clear my calculator.
It's true. Yeah, that's true. No, it's not. It's not what I have to say. No, I'm true.
Okay, I like what I'm seeing. Yeah, questions?
No, sorry.
Okay, help me out. So the number here for sodium, phosphorus, and oxygen off the periodic table, 1 mole per 15.999. 1 mole, who's got phosphorus? Brinkley?
Phosphorus, 30.9.
30.9, 74, and sodium, 23 something? 22.990, 1 mole, grams. Okay, divide, and we get, Kristen, first one, sodium?
1.83.
1.83, second one, Olivia?
0.61.
610, and the third one, Hannah?
2.44.
2.44. Good. If you're astute, you can sort of see the 6. 6 times 3 is 18. 6 times 4 is 24. But if you do it out the long way, it works out too. So you're going to get 3, 1, and 4. If you get this middle one wrong, it's going to mess you all
I had
up.
it right. I just thought it was an 8. It looked like an 8.
Oh, okay. So 0.61 divided by 0.61 is 1. This divided by 0.61 is 3. This one divided by 0.61 is 4. And almost everybody got here, so I'm proud of you. This is awesome. Na3PO4. Somebody tell me the name. Houston.
What?
Houston.
Sodium phosphate.
Sodium phosphate. Nicely done. Okay, it should look familiar. Na3PO4. Not the one I'm looking for. So we're going to keep working problems. You can do that. I'm excited. So excited. Okay. Oh, 31's a killer. Oh, yeah. 31, same page. Beryl. Beryl. When I was in high school, my wife-to-be, was at the time my girlfriend, bought me a little stuffed animal. It was a little dragon, a little green dragon. And since the stone known as beryl is a green-colored stone, I named him Beryl. My name starts with Barry. Barry and Beryl. So, here's my little buddy. And so beryl is cool. It's a hard mineral that occurs in a variety of colors. Green is the most common, by the way. 50 gram sample contains. Ooh, what do I do with that 50 grams? That sounds weird. But let's figure it out. 2.52 grams of Be. Now slow down on this one because this one's different for some reason. 2.52 grams of Be. It's not percent. Don't jump to conclusions here. 5.01 grams of aluminum. 15.68 grams of silicon. And 26.79 grams of O. 26.79 grams of O. Cool. Now some of you might be tempted at this point to change them all into percentages. Every problem we've worked for the last 3 days starts with percentages. You say, well, I can change these in percentages. It says it's 50 gram sample, so I just divide this by 50, this by 50, this by 50, this by 50, and I'm going to get percentages. But what's the next step after you do that?
Now in the grams.
You're going to change them all back into grams.
They're already
So why do I want to change something into percentages and then change it back into grams? So if this is the correct numbers, and they're in grams already, then we're one step ahead. We've already done the first step. I don't need to know percentages. So let's go straight to moles. So our next column, since this is already in grams, I can go straight to moles. Put your conversion factors in here. Oxygen, 999. And these ones we need to look up. Silicon, 28086. Aluminum, 26982. And beryllium, where we get the name beryl, by the way, beryl, beryllium, they both start with the same 5 letters, is 9.012. Calculator punchers. Got BE done.
I just brought it up to 0.28.
0.28. Who's got aluminum? Michael?
0.19.
Houston?
0.56.
I'm taking your word for this because I didn't do this one yet. And Houston?
1.67.
Okay. Next step. Divide by
0.19.
0.19. Aha, I think I found the problem I need. Let's see. Okay, so my ratio, I'll give you a minute to punch those in your calculator, see what we find. No, don't do that. Nope, don't do that. Nope. Okay, let's see the numbers and let's figure out what to do with them, okay? So this one's different. Okay, what's this come out to be? Somebody, Brinkley?
1.47.
Okay, 1.47, saw that number. Don't round it off to anything yet, okay? This one? 1. Okay, that's easy. This one here, Kristen?
2.95.
2.95, okay. And this one down here, Adriana?
8.79.
8.79. We're not done, okay? So they have to be whole numbers. So we have a choice. We need to find a way to make all of these the same. That's where. Yeah, no, that makes sense. Okay. Let's try this. Why is that?
Oh, yeah.
26.79. Is this right? Is this number here right?
Yeah.
The 8? Is that 8.79 or 8.29?
7.
I just brought the table.
Well, it's really 1.674, and then you divide it by that, but I think it's 8.811. Does that help any?
And not much. Okay, so if this happens, we need to come up with a way. How do I get all of these to be whole numbers? So the easiest way is we're going to say this is approximately 1.5. We're going to say this is approximately 3.0. And this is the oxygen, is the one I'm struggling with here. We're going to call that approximately 9. So if I have 1.5, 1, 3, and 9, we're in pretty good shape, with the exception of which one?
1.
So how do I get 1.5 to equal a whole number?
Multiply by 2.
Multiply by 2. Okay, so this is, remember, 1.5. 3 halves. 3 halves times 2. So we actually go through and we will find a number to multiply all of these by that gives us a whole number. So this comes up to be 3, 2, 6, and 18. That's where they got the answer. I have a hard time rounding 8.8 up to 9. That's just me. That's what the answer is, okay? So beryllium is, or beryl is Be3 Al 2 Si 6 O 18. Now, if you know anything about rocks, rocks are based on silicon dioxide. This would be for us a fine answer, but I know a little bit about rocks. So silicon dioxide is SiO2, so it probably looks like this. Al2 SiO2 parentheses 6, because silicate SiO2 I think is a polyatomic ion. Okay, we'd have to look it up. And beryllium will still be E3. Okay? Emily?
Oh, never mind.
Okay. This brings up the point, I've been looking for a problem, so give me the last 2 minutes here. If you found something over here that ends in something very close to 0.5, then we're going to multiply them all by 2. How about if you saw one that ended in 0.333? Okay, multiply by 3, because this is 1/3, this is 1/2. How about if you saw one and you just couldn't, it just didn't make sense unless you had one that ended really close to 0.25, okay? And when you multiply all of them through, you get whole numbers, and it works out, you multiply by 4. So this would be times 4, times 3, times 2. Okay, so you may occasionally see one where you get stuck, you get the mole ratios like, what? Okay, so look for a way to multiply by something to get rid of that one straggler. Now notice half is easy to spot. Another one that's not so easy to spot would be one that ends in 0.666. That's going to be 2/3, right? 2/3 times 3 gives you 2. Right? And if you had 0.75, that's 3/4. Again, we follow the same rule here. Okay, so just be aware of this. Put a little star there. Which one? 3, because it's 2/3. 2/3 times 3. Any number plus 2/3 times 3 is going to get rid of that fraction. Okay? Have a great night, guys. You got no homework. We'll be here tomorrow to do some final wrap-up.
Back to that problem. Go back to that problem.
Are we still going to do this?